scientific notation. What it's going to do, it's going to help us write big and small numbers more easily, more simply. And the reason why we need to do this here in chemistry is atoms are small, and the number of atoms that are in things is huge. As we'll see, writing all these zeros kind of stinks, so if we can eliminate that, make it easier to see, kind of show magnitude, big or small, once you kind of get used to it, scientific notation becomes much, much better. Correct scientific notation, how it's always going to look is it's going to look like a number, a decimal point, and then maybe some other numbers. And how we determine that is how many sig figs do we need, and then it's going to be times 10 to an exponent. That exponent can be positive or negative. We'll talk about which case, when you need each case here in a little bit. So rules for writing scientific notation. First thing is always find the decimal. I put it in quotes here because some numbers don't have decimals. It just depends on, again, significant figures. So once you do that, what you want is you always want that one non-zero digit in front of that decimal. So start there, and then again, only one to the left. The remaining sig figs go to the right if you need them. And then that exponent, big numbers get a positive exponent. So things like million, billion, trillion have positive exponents. Decimals, small numbers, get a negative exponent. And those come from which way we move the decimal, which I'll show you here. And last rule, if you need to move the decimal to the left, the exponent's going to become positive or bigger. Watch bigger though, it gets kind of screwy when you're around 0. And then same thing, if you move the decimal to the right, it's going to be opposite. It's going to be more negative. Again, watch things around 0, negative numbers that were smaller, I use caution with. All right, so some practice. So, write the following in correct scientific notation. Step 1, find your decimal. I don't see one, but I know that there is kind of one right here on the end. And then I want to make it so I have the one non-zero digit to the left of the decimal. Well, my only non-zero is this 1 right here. So I want to move my decimal so it's right there, just to the right of that. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I moved it 12 spaces to the left. And what it's going to look like is 1 point. Well, sig figs, there's only one, because again, trailing zeros with no decimal. We talked about that. None of those are significant. So I can leave this decimal here or not, it doesn't matter. But then it's times 10 to an exponent. Well, which way did I move it? I moved it left, so big exponent. And I moved it left 12 spaces. So final answer, 1 point. You can leave it, you can get rid of it, whatever. 1 times 10 to the 12th. Letter B, same thing, find your decimal, found it. And I want to get it so I have one non-zero digit to the left, so that would be, I want to move it here. So how many spaces is that? 1, 2, 3, 4. So sig figs, I look at it, I have 3 sig figs, so I want my answer to show 3 sig figs. 4.56 times 10, like always. And then I moved it right this time, so I'm going to be negative. And I moved it right 4 spaces. Letter C, looks like it's in proper scientific notation. Has a times 10, has an exponent. But if we look, we have 2 numbers to the left. So we got to change that. Same as always, find your exponent. Or sorry, find your decimal. Decimal's here, I need to move it 1 place over. Looking here, all of those are significant, so we'll record our answer 3.20 times 10. Well, okay, I just can't say it times 10 to the first because I already have an exponent. Well, which way did I move it? I moved it to the left. So since I moved it to the left, that means this gets bigger or more positive. 10 to the 6th. Letter D, same thing, except I put 2 decimals in there. I don't know why. We'll go with this one. Same thing. Looks kind of like proper scientific notation, but it's not. So I want to move it here. So to do that, I need to move it 1, 2, 3, 4, 5 spaces. So we'll report our answer as 6.59 times 10. Well, okay, I was at -8. I moved it to the right. So if I move it to the right, that means it's more negative. So we moved it 5 spaces to make this more negative. So a -8, that's 5 more spots. Negative is -13 is our final answer there. Kind of a tricky one. Even more tricky when I put 2 decimals in there. Moving on. Doing the opposite. Write the following in standard form. So how does this look if you would normally write it? All right, so 3.44, it is correct scientific notation here. It really doesn't matter if I give you correct scientific notation or not. You just need to know which way to move the decimal. And what you want to think about is, okay, how do I make this? So this is basically times 10 to the 0, because that's times 10 to the 1. Or sorry, times 10 to the 0 is 1. So to do that, I need to make it more positive. So to make it more positive, I move it to the left. So 3, 4, 4, the decimal here. And I want to move it 7 spaces to the left. So there's 1, 2, 3, 4, 5, 6, and 7. So our new answer is 0.000000344. Again, the reason why I moved it left is because I wanted to make it more positive to get this in standard form. Letter B, it's doing the opposite. Okay, again, I want to make this times 10 to the 0, so it's really times 1. So to do that, I need this to go more negative, so I'm going to move it to the right this time. So 3.44, and then to the right. Well, okay, 1, 2. I need more spots. 3, 4, 5, 6, 7. 3, 4, 5, 6, 7. And then you can clean this up. 3, 4, 4. 34,400,000. And the last one here, just a little practice for you guys, kind of like what we just did. Write the following in correct scientific notation, and then write the following in standard form. Good luck.